Welcome, I guess. Welcome to another live stream from Moment. So Moment is a no-code full stack dev platform, and uh, today we'll discuss mostly on a somewhat on a philosophical level, um, what like uh, what the future of, let's say, software construction is going to be. Is it going to be code, no code? How do we get here? So the overall impression nowadays is that um, is that like no code is going to be replaced by AI coding. So the players that are prominent are categorized in like two separate categories. You got the co-pilots, which are the cursors, the windsurfs, um, the GitHub Copilots. Two of which I have paid. I've paid for Cursor and GitHub Copilot. And then there's the other part, which is like the fully automated AI coders, which are like Bolt.new, V0, and nowadays Devon, which costs like $500 a month. Um, so the promise of them are all fairly similar. It's supposed to be easier and faster. We'll go into how each of them are slightly different later, but I'd first like to uh, tell you like how we got to where we are, right? So before the whole thing was no code or AI coding, we had coding. And by the time we're in this web era, we're mostly looking at high level languages such as JavaScript, Java, or Python, or whatever. And typically, for somebody who's completely uninitiated in the coding world, takes them about I would say conservatively at least 6 months to be able to produce a piece of valuable software that serves a reasonable sized customer base. By reasonably sized, I mean at least in the tens, right? So that means you will have to have this thing hosted somewhere. You need to be able to monitor your servers. You need to be able to handle like more or less seamless upgrades, or at least you have to set up some kind of upgrade um, scheduled downtime, and all that. And 6 months is probably an understatement. So it might take you like a whole year to be able to do front end, back end, all the API hookups and deployment, and setting up a proper pipeline. And with that, you have complete freedom, almost, because you will be relying on some cloud infrastructure that's going to take away some of your freedoms. But the flip side of freedom is always responsibility. So um, people, you would have to bear the responsibility yourself to maintain everything. And then in like 2015 or later, you end up with this no code movement. I think one of the pioneers would be Bubble, right? They started in 2012, but the idea of no code goes way, like the original idea goes way before Bubble started. Bubble started in 2012, but we had like this thing called the fourth paradigm or something. Basically, it's some kind of visual coding and sorry, visual programming. And why we needed visual programming? Because code is linear. It's structured linearly, and therefore it does not necessarily help us too well to understand anything. There's no spatial cues. We try to help ourselves a little bit with indentation, but that's about it. you got indentation, and you got this whole free flowing free flowing text. That's what we have. And then we try to help ourselves a little bit more with syntax highlighting, and even like traversals, right? If you command click on something, typically in any reasonable IDE, what we are looking at here is cursor. It will take you to where the thing is defined. So that's as far as things go. But with something like no code, there's a lot more freedom for you to express the information. For example, to edit the front end, the left side and the right side of the screen would change based on what you have selected, and you get a more immediate feedback from the actions. So that kind of helps you learn things much quicker. So I would say by the time like no code really took off, which is like probably 2021, it is reasonable to expect somebody to build something that's more or less functional in a week. We have tested it in 2021, in fact. We had two interns who studied, one of them studied stats, the other one was either math or something. So they're smart people. They're just they've just never coded things before, and they were able to build a fairly sophisticated application in under a week. And that application was to track the different requirements and different. It's like a simplified Redfin, but for Shanghai. But it's commercial, so it has all the integration with maps and the searching and different ways of displaying data. And obviously, people need to be able to update the data on the back end. So yeah, so a week was what we were looking at. Now, with AI, like AI came into the picture in about like 2023, early 2023, when we had GPT 3.5, and then like GPT-4 came out, and then it's even more useful, right? To me, with code and AI, I think it is feasible for someone to learn how to build something in under a month. And it's not that the AI made coding any easier. AI just helped people understand what code is. So, for example, I could just select this, right? I can just chat to it and say, what does this mean? And that will explain things to me. And that's something that we never had the chance. It's like you always had a tutor next to you. The tutor might not be top tier. It's he only knows more of the superficial stuff, or sometimes AI knows more than just the superficial stuff. But you could do that, and then maybe I'll ask something more. Let's say, what, like, why should sales chart prop data have casing like so? Okay, and that would explain things to me as well. And this was something we never had access to. And that's why I think with AI, everyone that's, with an IQ over, let's say, 110 should be able to learn coding and build something in less than a month. That's something that we couldn't do before. And also, other than like just explaining stuff that's in code, it could also explain things to us when we had outputs. A lot of times you got a bunch of logs that comes out, and to the untrained eye, it's just a bunch of gibberish. Like, for example, this guy. Okay, for example, this guy. What does this even mean, right? What the hell is error TS6133? Well, if you were trained, you know to look this up in Google. TS6133 is something that you can use to search because it's a very uncommon term. And it says use state is declared, but its value is never used. Well, what am I supposed to do with that? Okay, so you could just say, what am I supposed to do with this? Okay, and then maybe we don't even have the file. Which, what am I supposed to do with this? It says blah, 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 blah. It says you just remove it. Right? It just basically means just remove it. Okay. Now, with more and more of this kind of examples, I then can understand the patterns behind code. And we are pretty good at pattern recognition. It's just that when you have this huge blob of things thrown at you, you get lost. Like what the hell is going on in dummy is probably easy, but this whole thing, right? It's really long. For example, this guy, we could ask like, what does this mean? So this is the crucial thing with AI, I think, with coding. And going back to the two categories of different AI coding tools, in my opinion, copilots like Cursor, GitHub Copilot, and Windsurf, these are best suited for either studying things or actual professional coders because they can generate code for you. And I would say that the code it generates is 60-70% of the time correct. The shorter the snippet, the higher the chance it is correct. And obviously, as a software engineer, a professional software engineer, most of the time you're not actually typing code. Most of the time, you are just there thinking about how to do the code. You're trying to design more than you're trying to code. And I would say the actual coding time is probably 30%. And if AI is able to speed it up by 2x, then you get like a 15% productivity boost. Obviously, you can use AI in other parts, like you can use AI to help you design, and you can use AI to help you debug, but that's a separate issue. That's not what these copilots are supposed to be doing. And then obviously, what as I said, it helps the uninitiated quite a lot. I can start letting AI generate things and ask them what it means. And AI is very good at translating things that's in code into human language. So that's nice. And the other side is the auto code generators like Bolt.new and V0. Well, they have this promise of almost like speak to from speech to software. And I think, well, the worst offender of that is Wegic, which is like supposed to be like a no code one prompt to generate your website thing. I don't like their approach because it's missing a lot of the information collection. A normal software is constructed with a lot of backwards and forwards in terms of information. The stakeholder would have a bunch of requirements, have use cases in mind, and that has to somehow be communicated to the actual implementer, which is the software engineer. And most of the stakeholders don't even know before things are built, before they actually experience it. They don't even know if the thing they had in their mind is even correct or are consistent, right? So having this illusion of writing out just some code, and I think it's over promising things, right? And there is a good way of doing it, which is putting the human in the loop. For example, if I were to do an autocode, like an actual automatic like software constructor using AI, there will be a lot of places where I would instruct the AI agent to ask for more information from the user, because only the stakeholder, which is the user, knows exactly what they want in their mind, and they might not even know it. You have to clarify their minds with them. That's, I think, the a lot of times what a software engineer ends up doing. That's why we have collaboration between software engineers and product managers, and even like salespeople. You need that information to get distilled down to something that's implementable by code. It's some kind of rule. It has to be compressed down to some kind of rule. Okay, and Devon is, I think, doing mostly the correct thing here, because they have a fairly agentic workflow, and from what I saw, it was quite complete. It starts out with a plan, and then it would drill down in that plan to solidify it, basically, and then execute on it. It still makes mistakes, but that to me is very similar to how an actual human would solve this problem, and I think that's the correct way to go. And well, for automatic code generators like Bolt and V0 and Devon, one nice thing is that they provide infrastructure. So Devon probably not. Devon just provides an infrastructure for the editor, so that you don't mess up your own computer. Because I really don't want some AI agent to randomly mess with my operating system and deleting my files. Uh, so Devon creates its sandbox, but for most of the software that we construct today, they are to be running on the cloud. It needs to be publicly accessible by your users who might be from the other side of the world. And if you're using Cursor, then you're still on the hook to find a place to host your program. And Bolt or V0 kind of solves that for you, because both Bolt and Vercel has existing infrastructure which you can run things on. So I guess it's more like a software constructor plus a platform as a service, like 2-in-1. So yeah, so I guess like the common pitfall here is whenever you're using AI, you have this illusion of power. So going back to my own thing, right? So this was not too bad. I had another project which I was trying to mess around with about 6 different tables that all have relations between them, and I was trying to fetch some of them and fetch all the related stuff and update and then write back. I was using Cursor to write all that code, and it failed miserably after starting off out on a really high note because I got like most of that code done in less than, I would say, an hour. But the sad truth is, just like our professional software developers, most of our time we spend on debugging. We debug, we maintain, we try to iterate. As new requirement come in, as we run into more bottlenecks, and as we discover like what we wrote was wrong. So that was very, very painful. I had to repeatedly send these things to the chat to make Cursor to tell me like how to change things. And when I changed things, it would take me from one wrong answer to another wrong answer. And sometimes I would look very carefully and try to understand exactly how it got wrong and tell Cursor to change things again. And it would always very respectfully tell me, "You're absolutely right. Here is what we should do," and then the answer will be wrong again. So that's a sad truth. Not only, well, you might say, okay, why don't you just get rid of at some point? Why don't you just get rid of Cursor and just iterate on the code that it has written? It has two problems. First of all, the code that Cursor wrote had too little influence from me. So the corollary of that is I don't know what the heck it was writing. And yeah, because even for someone like me who's been writing code since like 1998, um, it takes time for what the code does to sink in. When you're writing it yourself, obviously, right, your mind processes the information faster than you're able to output it, you typing. But when Cursor is just spewing out code, it's very difficult to keep up. That's one thing. Secondly, only people who's already trained in coding can take over. And I think that's the biggest pitfall here. You get this illusion of power. You can bang something out really quickly. You don't bang it out. The AI does. But then when you want fine-grained control, when you're at the limit of the AI, because you don't understand, you can't change the code. You still have to go through the 1 month, which is what I mentioned before, the 1 month ramping up, learning how to code with the help of the AI and being very concentrated before you can even start changing that. Because most people will be at a loss when they're looking at this. This is not difficult code. This is fairly simple stuff. It's just some GraphQL. But to people who's never written anything, this is horrible. Right? I have no idea what the hell this is doing. So yeah, so the illusion of power is something that I think is best kept at bay, because you see like these sensational stories about like a kid writing games in Cursor. Well, yeah, but who plays this game himself, and not too long for not too many times too, because the reason the game existed is because the guy didn't really care what the game actually does. If he really cared about how the game functions, well, just asking Cursor to do things probably wouldn't work. And also, that thing had no state, which is like the most difficult thing in state maintenance. Any kind of state maintenance is the most difficult thing you can do in software engineering. The prime example is caching and cache validation. It's a horribly difficult thing to get right. And so the way we interact with AI is either, do my bidding or give me suggestions or explain things to me, which is, I think, very reasonable. Now, when people say that AI and coding is gonna get rid of no code, I think they're onto something, but they are comparing code plus AI versus no code, not code versus AI versus no code plus AI, right? AI is like this booster, it's this supercharger. And the reason we had code plus AI first is because code is more popular than no code. And obviously, people's gonna build uh they're gonna build tools around things that's already more popular than things that are not as popular. So that means the no code platforms will have to invest on their own to integrate AI. We won't have the luxury of having somebody else building it, right? Cursor is building AI Copilot for programming in in C, in Java, in TypeScript. But what if you invented a new language? It's the same thing. If you invented a new language, it wouldn't be able to help you. Well, no code platforms are like new languages. In fact, they're like new languages plus new runtimes and new deployment environments. Well, then you, as in the whoever developed the new no code platform, will have to figure out ways to deal with the lack of knowledge in AI. One way is that you could fine tune. That's one thing. If your world doesn't change too frequently, fine tuning for the knowledge of your platform is probably very useful. Or you could do the more clever thing. So there's a place called Common Crawl, and I've been searching Moment, especially the documentation, docs.momen.app in here. And you can see here we have nothing that's docs.momen.app, which is unfortunate. I really wanted to be in here, but for some reason in December it's in there. So I don't know, something wrong with Common Crawl. The significance of Common Crawl is that this is like the basis of every single large language model. This is the cheapest and this is the cheapest training material one can get because it's free. So there's no way any large language model is going to pass up on Common Crawl. They're just going to use it. So one way is to get yourself into Common Crawl. Okay, so that will teach all the large language models about your product. And the other way is you just write very extensive and comprehensive prompt. You tell the large language model all the rules about yourself every single time you interact with it. It's going to be expensive, but not as expensive as you might have thought. For example, if you go to platform pricing, right? GPT-4o Mini's input for 1 million tokens, that is, you can approximate that to like 1 million words, is 15 cents. Okay, so that means, well, and also you can make it even cheaper if you cache it, and which is most of the time, like, you will be caching those because your documentation doesn't change. Most people don't have documentation that's 1 million words long. We probably have them at 1/10 of that. So every time somebody asks a question, worst case, if you don't do any chunking, if you don't do any retrieval, you don't do anything smart, you just jam everything in, it's going to cost you 1 cent per question. It's expensive, but not unbearable. And also, the cost of inference is going to keep reducing because the cost of inference is a function of both hardware compute, cost of compute, and also the efficiency of the inference engine. We are making progress on both ends, so I personally I predict to get the same quality inference, right? Next year, we're looking at maybe like a half to even a quarter of the cost. So by next year, the equivalent of GPT-4 Mini's output is it's gonna cost you like quarter of a cent for 100,000 tokens. So next thing that a no code platform developer should do, in my view, is that they should incorporate more than just text. For example, this view here is very useful for any large language model with a with a visuals. So let's just go to ChatGPT. Okay, let's imagine that I want to. Well, this thing's called Udemy because I'm trying to mimic a Udemy. It's something that I just built. So let's say I want to make this page. I want to have the page show, say, Udemy instead of something, right? I want this page to show up as Udemy when I open the resultant website on my browser. On my browser tabs, in my browser, whatever. Shit English, doesn't matter. That's okay. So this ChatGPT is gonna recognize this. It says set page title to whatever, save and publish, verify in browser. Okay, why is that? Because we try to make things easier for humans. Anything that's easier for humans is gonna be easier for AI. And I'm just asking it to do something that's really simple, and this is not even optimized for AI. We can combine the visuals and also expose AI the portion of the data that might be relevant, and it will be able to produce a very reasonable suggestion, simply because like we have taken away a lot of the choices, and difficulty is a function of the number of choices you have to achieve that goal. If I have a single choice to achieve that goal and I know what that choice is, the difficulty is essentially zero. But if I had a million ways of doing the same thing and I want to be optimized in the way that I do it, then it's a very difficult process. You need ways to measure the efficacy of each method, and then maybe you need heuristics to help you choose it. That's just the nature of things. So once we made the problem at hand easier for humans, I think it's going to be easier for AIs. Obviously, the AI is not going to be as effective working on something that's proprietary, such as a no-code platform, then it will be on code because, well, you don't have GitHub, right? You don't have a GitHub for Moment. You have no GitHub for Bubble. You have no GitHub for Flutterflow. And even if you did, how do you encode the stuff that how do you encode the stuff that people edit visually to the training material? Because this is going to be a sequence of things and a sequence of actions. And this spatial relationship does not necessarily get reflected in the resultant domain specific language, and domain specific languages are usually how these no code platforms are built on top of. Right, so that's something that we will have to solve. Okay, so lastly, in terms of how a no code platform should leverage AI, I think, is by opening up the code. And that brings me to the last topic, was basically the dichotomy of code and no code is false. So we have code component. And in fact, what I was showing you in cursor here, this is a code component for Moment. It is mostly standard HTML, React. We specifically built it to use React so that people don't have to learn something that's esoteric. Right, React is very popular. You get a lot of React developers, and then we try to impose as few platform-specific rules as humanly possible. So we have like 3 rules. This is the way you need to do it, and then we have a utility function called use app context. That's all there is. Um, and yeah, so that will enable us to leverage, or our developers to leverage the power of AI, and we just need to give essentially build a prompt template for our developers so they could use that. And maybe the better thing will be like you can create some code component right there inside the moment editor. And that's the front end part, right? And then we also want the back end part. Why don't we have JavaScript running in here? And admittedly, we are not doing a good job in terms of the back end code, because yes, we're using JavaScript, but we're using it as a script, not as a module. So to those who know, like there are slight differences between. So, and also we had this special thing called context, which hides a lot. Well, which hides a lot of functions in it, and this is also a. It's close to like a V8 environment than it is to a Node environment, so you can't import existing libraries. So that's something we're going to fix next year, probably early next year. We already know how to do it now. But this can be generated by AI. In fact, this kind of snippets, it's not very long. It's very constrained in terms of its scope. And it's performing usually a single task. That can be done by AI. We could very well just have something that says like, describe to me what you want to do in this code component, and code node, and the AI might generate a lot of things for you, and obviously we need to tell it the rules. So that's one. That's, as I said, that's the last thing to as a no code platform developer we should do to leverage AI. So you could have it assisting the client, the developer editing your no code configurations, or you can have them just writing actual code for you and integrate them. Now, the advantage of code, and well, so let's bring it back. I was going to say, like, there's this false dichotomy of code versus no code, and the main reason is that we don't really care. Nobody really cares whether things are done by code or no code. People care about how easy or how fast it is to construct software, and then how expensive it is to run, and how scalable things are, right? So those are uh, the metrics we're trying to hit. Whatever system covers the biggest area, if you think each one is like a spoke coming out, right? Whatever system covers the largest area is what the best system. And there's no need to really think about whether something is code, no code. And then people say, oh, why then aren't you just low code? Well, yeah, low code, no code, who cares? What you really want is just flexibility, performance, cost, observability, and yeah, the things that are common to software engineering. These are not things that's specific to coding or to a no code platform like Moment. And so the impression usually people get from a no code thing is like, okay, you lack flexibility because there's platform limitations. Um, you cannot leverage existing assets. Uh, by existing assets, I mean like these logical assets, things you can pull out of GitHub. Bubble does this quite well. They have a plugin system, and those plugin systems is exactly what I mean by existing assets. These are things that are already there that might provide value to you. So by being open to importing code and having the integration of code versus and code and no code part, then we open the door to leverage existing assets, namely GitHub. And performance, right? So this is a common issue that people associate no code with low performance. And we are mostly to blame for that. People that are in working on no code is mostly to blame for that, and that makes perfect sense, because if we write shitty software, it's going to be not very performant. But that's not something that is inherent to no code. It's just poor software. It's just bad software. So the idea is that we need to write good software, and then that can solve. Then performance doesn't. No code doesn't have to be bad performing. In fact, in Moment, we had supported an application that served 120,000 daily active users with just 4 cores and 16 gigabytes of memory. And that's $480 to the customer per month. So if you had bad engineers working for you, it's very likely you can be spending a lot more money than my customer did on Moment. So performance, I think it is something that is squarely on bad no code platform. It's not on the no code. No code doesn't have to be slow, basically. Cost, okay, people say, oh, we choose code because code is cheaper. We can migrate. We don't get locked in, and the cost is more predictable. Well, you can have a lot of that problems taken away if you were using no code. Well, if the no code platform itself does the things correctly. Okay, so unpredictable cost. you can have unpredictable costs in code as well. You run a serverless, you run anything that doesn't have a cap, you end up with unpredictable cost. Lock-in is usually not an issue unless somebody raises their prices on you. And that's what happened with Bubble. That's why people are really afraid of lock-in now in no code. But such thing can happen in AWS as well, just because AWS just doesn't do it. If you use DynamoDB and AWS increases their pricing on you, there's very little you can do. You just trust AWS to not do it. And I think as a no-code development platform, we should give developers that sense of security. Plain high prices, well, as you add on more abstractions, you need to pay these engineers, right? So yes, that's going to be higher prices, but by how much? So it really depends on how much you can spread that cost over. Yeah, so observability, again, that's going to help AI as well. Logs and the ability to search the logs. And one thing that is admittedly that no code is going to fall behind is the proprietary stack traces. Stack traces are the things that we use very frequently. It's one of the most important tools that software engineers have to understand what went wrong or what the hell is actually going on in a system. Now, a common framework like Spring or Django or Express will have stack traces that AI knows about because people discuss them online. It's on Stack Overflow, it's in Reddit, it's in whatever chat. But stack traces for most no-code platforms won't be as popular. But then again, it's not a problem with no-code. It's a problem with any framework that's not popular. It's a problem of popularity. And then, codes have like debuggers and profilers. That's just toolchain. Ideally, a no-code platform should have them too. We don't have them. That's because we're just not as mature. The number of people working on the ecosystem is much fewer, right? For example, in Momen, we have 20-something engineers. Wow, the number of engineers working on C++ toolchain is probably tens of thousands. Yeah, so I guess I went off in a tangent because I really want to get this out of my chest. I wouldn't say I had a conclusion. The idea is that we are currently looking at comparing code plus AI versus no code. Code plus AI has huge advantages compared to what was there before, which is just code. It enables people to learn things faster. It allows people to actually construct. It makes you more productive if you know how to use it. But we haven't seen much no code plus AI yet. I think with no code plus AI, it's probably reasonable to expect people to learn the whole platform and be productive in a day instead of what used to be a week. And there's pros and cons to using a no code plus AI versus code versus AI plus AI in terms of like the difficulty of actually constructing an AI solution that works. Code has a GitHub, no code doesn't, but code is more difficult inherently because more choices, more freedom, and no code has fewer choices, which makes it easier for AIs as well as humans. Yeah, that's all I wanted to say. And thanks for listening to me ranting about these things. And does anyone have any questions, any comments? And I'm happy to take a few. We have 10 minutes. If not, we can end early. Okay, I think that probably means no. And call it let's call it a day then. Thanks all for coming, and it was even though nobody commented, and I'm pretty good at talking to what seemed like a wall though. So good night or good morning to whoever is on the other side of the globe. Bye.